Hello there, welcome to the October 2020 paper. Here we're looking at question 1. So a system of three equations is defined by kx plus 3y minus z equals 3, 3x minus y plus z equals minus x, and minus 16x minus k equals k. Where k is a positive constant. Given that there is no unique solution to the three equations, now as soon as I read that line there, that tells me that the determinant of this matrix is going to equal 0, because if there was a unique solution, I'd be able to inverse the matrix and move it to the other side and find that unique solution. But given that I can't, the determinant is equal to 0. So show that k is equal to 2. Now the essence of this question here is show that the determinant is going to equal 0 when k equals 2. So if I now, whoops, no, I don't want to put 2 in there. I'm going to still use k, so I'm going to write out the matrix that would be formed by this system of equations. Just like that, and now I'm going to work out the determinant of this matrix here. So the determinant equals, so start from the top, it's going to be k times, and then you delete the row, delete the column, and then it's going to be a crossing multiplying maneuver. So it's going to be k minus k, so that would be plus k, and then you move across, but remember the matrix of cofactors, plus minus plus, minus plus minus, plus minus plus, in the top middle cell it's a minus, so it's minus 3 times, cross out the row, cross out the column, minus 3k minus 16, so that would be plus 16. Then moving on to the final one, that has a plus in that position, so it's a minus 1. And then it's going to be 3 times minus k is minus 3k. Minus 16, so that would be minus 16. Equals 0, if the determinant is equal to 0. So therefore, it's going to be 2k squared plus 9k minus 48 plus 3k plus 16 equals 0. Okay, let's go ahead and solve this now. So it's 2k squared plus 12k, and then minus 48 plus 16, that would be minus 32. Divide by 2 and you get k squared plus 6k minus 16 equals 0. So therefore now we'll factorise k plus 8, k minus 2 equals 0. So therefore k equals minus 8 and k equals 2. So therefore, given that k is a positive constant, the answer, so this one here is positive, so therefore k is definitely equal to 2. When the determinant is equal to 0, the value of k equals 2. Okay, let's move on to the next part. Using k equals 2, determine whether the three equations are consistent, justifying your answer. So what I'm now going to do is I'm going to replace all of these k's with 2. So 2 here, 2 here, 2 here, 2 here, and 2 here. So first of all, I'll just do a quick inspection to see if there's any parallel planes or coincident planes. So there's no plane that will scale factor up to another plane, so no, there's no linear planes. I know that the determinant equals 0, so now I just have to treat this as a solving simultaneous equations kind of question. So this here will be my first equation. The next equation will be 3x minus y plus z equals minus 2. The next one will be minus 16x minus 2y minus 2z equals 2. So I'll call the first one equation number 1, second one equation number 2, third one equation number 3, and I'm looking to eliminate one of the different variables in a couple of different ways. I think I'll eliminate the z variable. That looks like it's the easiest to eliminate. So if I add equations 1 and equations 2 together, that will eliminate the z variable. So it's going to be 5x plus 2y equals 1. And now I need to do it in a different way. If I do 2 times 2 and then add it onto 3, then that will eliminate z as well. So if I do 2 times 2, that would be 6, add it on to 3, that would give me minus 10x. Times this one by 2, add it on to 3, that will give me minus 4y. That will cancel out the z's, and times the 2 by 2 would be minus 4, plus the 2 that would be minus 2. So what's the scale factor from this one to this one? It's a scale factor of minus 2, and it will also work on the number at the end. So these two equations here are the same. And if they are the same, the posh word for them being exactly the same is coincident. So there we are, they are coincident. Hopefully I've spelt that correctly. Oh, consistent. So it's to say coincident and consistent are exactly the same kind of phrases. So there we are. There we are, that's the answer to part B, and moving on to the answer to part C. Now, through the working that we've done in part B here, I can tell that the 3 planes are consistent. I can tell that the 3 planes are not going to be parallel and not going to be identical to each other, and they're not going to have an inverse, so therefore this forms a sheaf. Effectively what a sheaf is all three planes will intersect along the same line, will intersect along a common line. Hence giving us infinitely many solutions to the 3 intersections of these planes along a common line. Okay, so there we are, that's the answer for this question here then. That's the answer to question 1, 6 marks there. Let's now move on to question 2.